In this video, we're going to talk about place value in algebra. So I want you to think of place value like you thought about place value when you were in elementary school, maybe second or third grade. So we're going to do the same sort of idea here. So what I'd like for you to do is pause the video and go ahead and draw this little chart. Make sure you have plenty of room on the top because we're going to be writing some information there. And keep your columns nice and wide. So now that you've copied this graph down, what I'd like for you to do is we're going to put a decimal right here. So the reason I wanted you to put a decimal there is because anything between the integer 1 and the number 0 are fractions, and we're not going to concern ourselves with fractions today. So you can see I've just kind of marked that off as fractions. We're not going to talk about fractions. So now what I want to remind you of is that when we looked at each of these columns, we would say that this is the units, this is the tens, this is the hundreds, and this is the thousands. So let's go ahead and write those in. So now that we've labeled our place values, we can go ahead and talk about what each of these things represents and how we can connect it to algebra. So over here, I'm just going to be writing down some ideas. So the first idea that I want to write down is this one. I'm writing this number here, and I want you to figure out what number you think that is. And if you said the number 1, I'm going to tell you, nope, that's not what I was thinking. I'm going to put the number 1 in this column, so now that means that I have 100. But in order for me to express 100, I had to put a 0 in the tens and a 0 in the ones. So now I have 100. I'm going to write down another number. What do you suppose that number is? If you said the number 32, I would say that's not what I was thinking. If you said 320, that's not what I was thinking. What I was thinking is I'm going to have 3020. So in order for me to express 3020, I have to make sure I have the 0 in the hundreds and the 0 in the units or the ones. So now you recognize that as 3020. So what I want to just point out to you that's very important is zeros have a value. So zeros are very important. They tell us not only that we have no hundreds and we have no ones, but it also tells us how we're going to read this number. So what I want you to keep in mind is that if I have 0 tens, that's the same as saying I have 0 times 10, which gives me the value of 0. So now what we're going to do is we're going to take this one step further, and we're going to start making a connection between place value and algebra. So if I were to actually write these numbers here, I'm going to write them on the top, I would write 1,000 here, 100, 10, and then like the number 1. But we're going to write this differently. So we have 10 fingers, so we operate in base 10. So that means our base, the number that we're going to be looking at, is 10. So how would I write 100 as base 10? That would be 10 squared. And 1,000 as base 10 would be 10 cubed. And then the other thing I want you to know here for units, that this is really 10 to the 0 power. Any number to the 0 power is the same as 1. So we're going to just keep that in mind. So I'm just going to say units, I'm just going to put 1 here. And if I were going to put an exponent there, that would be 10 to the 1. So then how would this look like if we were going to do it algebraically? Well, I've just given you a little clue. So if we go back to how we looked at things earlier, that this is a cube, which makes it volume. This is a square, which makes it a square. This is linear, because it has a degree of 1, which makes it a line. And remember, this has no dimension at all. It's just a dot in space, so that's what makes it that. So what I'm trying to do is I want to show you how if I were to pretend, so let's make x equal 10. So that's an important concept. So this is now how we're going to modify our chart. So notice this is the same as x cubed, x squared, x, and a constant. So you want to think of them as place value. So let's say I have two functions. I'm going to write this over here on this side. So if I have a function, I will call it f of x, and let's say that equals 2x squared minus 7x plus 8. And then I have another function. That function is going to be g of x because it's different from this function. I would call that 3x plus 5x, 3x cubed plus 5x minus 2. So let's say we want to do something with this function. Let's say we want to add the first function to the second function. So using function notation, I would say I'm going to add my first function to my second function. Well, I have to make sure when I'm adding or subtracting, I have to recognize place value. So this is very important when we're adding or subtracting. So that means we're going to transfer this information into our table. So if I want to add f of x, I'm going to look for my x squared column, which is right here, but I'm going to write 2x squared, and then I have a minus 7x, and then I have a constant of 8. I'm going to put the sign there. Now with adding, I don't have to worry too much about the signs, but I do have to worry about the place value. So look at right here, that's a cube. So this is going to go in this column. This is not a square, this is an x, so that goes over here. And then I have a minus 2. So you don't have to write this in, but it's important to note that in my function of g, I do not have any x squares. So that's holding a place value. So now I'm simply going to add like terms together. And that's why they're called like terms. So this becomes 3x cubed plus 2x squared, because that's positive. And then this becomes negative 2x, and then that becomes plus 6. So then that means that when I add my f of x to my g of x, this is what I get. Okay, now I'm going to put the addition sign here just to note that I'm adding. Now I'm going to do a second function. I'm going to do this one here. I am going to subtract, and you're going to see that I'm going to do it slightly differently. So I wrote everything in the same way I did before, but remember we're subtracting. So this is what I'm going to do. I have to remember I'm subtracting. So I'll write this off here to the side. I'm going to subtract. So that means that this is going to become negative, this becomes negative, this becomes negative, and this becomes positive. I'm just going to write this over here that that's what I'm doing. So I'm going to change all my signs, then I'm going to add. Well, there's nothing up here. I could have written 0x cubed if I wanted to. So this becomes negative 3x cubed. This doesn't change the value, so that's positive 2x squared. This now becomes negative 12x, and this now becomes plus 10. So you can see that there is a big difference between adding and subtracting.